Hello. Um, we are going to do statistics today and tomorrow, and the only thing we're really going to spend time on are measures of central tendencies, which is our mean, median, and mode, and dispersion means how is the data spread out. Going to go through most of this today is going to just be refreshing your memory and notes. There are 3 problems for homework. It's from the textbook that we would have had in class. But they're at the end of this packet. So you have the packet that's empty. I'm going to go through it. You need to write in your notes, and then your homework would be the 10, 11, and 12. So let's first talk about the mean. Now, the mean has a symbol, which is an X with the bar on top. And the mean is the average. It's when you add up all your data and divide by the number. So here is the symbol for adding, the sum from chapter 6. You're adding from the first piece of data to the last. So you're adding all your data, and then you're going to divide by the number, and fractions mean divide. So multiplying by 1 over the number is the same as just dividing straight by the number. So we're going to take the things we know and we're going to write them. This would be the mathematical version or formula that is universal throughout the world. Median is a middle. You have to have your number in order, and when your data numbers are in order, the middle value is called the median. So median is the middle. Just like when you're driving on the expressway, the median is in between, the north and southbound lanes. Now, mode, this is the value or values that occur most frequently in a set of data. And so when you look for something that is occurring the most, that would be called the mode. Now, we hear the words standard deviation. We're not going to spend too much time on standard deviation. If we were together in class, then I would have, but I'm not going to spend too much time. But the way our data is spread out, the way our data is dispersed, we look at it and analyze it, we give a value to it, we call that value a standard deviation. A small standard deviation means you have really, really good data. Your data is all close together. You have a good set of data. If you have a large standard deviation, that means your data is really spread out and you really don't have a very good set of data to be working with. The rule of thumb in statistics is the larger your data set, the better your numbers and the better your conclusions will be. Now, we're going to do this. It's too hard for me to type all this stuff, so that's why I have it up here first. But now let's talk about how we would do this on the calculator. The number of pets owned by children in the 6th grade class are given by this table. Now, if I'm going to use the table, I have to use the lists. And to get to the lists, that would be stat for statistics, and edit means I have to put my data into the lists. So if there was anything in here, I would clear these lists. See where it says memory? You would hit second, memory. Number 4 is going to clear all your lists. So here is stat, edit. And that's everything that's written right here. Clear your lists, stat, edit, enter, and we're going to enter the data, and then we're going to calculate the statistics that we need. Let's go nice and slow. So in list 1, I'm going to put the number of pets. Kids had 6 pets, kids had 5 pets, 4 pets, 3 pets, 2 pets, 1 pet, no pets. And now you hit the arrow, you're on the second list. 2 kids had 6 pets, 1 kid had 5 pets, 3 kids have 4 pets in their home, 5 kids have 3, 8 kids have 2, 14 have 1, and 7 kids in this class have no pets. Now, you always want to double check your list, so you go up and you check your ordered pairs, 0, 7, and you can even move your bar back and forth, because if you typed anything wrong, all you got to do is put this black bar on what you typed and you can fix it. So the next ordered pair is 114, 28, 35, 43, 51, 62. I always check my lists because, guys, you should know by now, I am the queen of making stupid mistakes. And typing something wrong is very easy to do. So once you know your data is right, now we're on this last part here. Stat, hit the arrow to the calculate menu, and then you're going to pick number 1, variable statistics. And we're not hitting enter yet. This is a 2-column table. So if I hit stat and I go to calculate and I hit number 1, I have to let this calculator know that it's the frequency with the number of pets. So I have to tell the calculator that list 1 is my data. So I hit second and 1, that puts list 1, the comma, and then I have to hit second and list 2 because that's now telling me the frequency of my data. The calculator knows this. It's written right over here too. Now, you might have a new calculator that when you hit number 1, when you hit stat calculate number 1, it gives you kind of like a bullet. It says list, and it should say L1 already there. And then underneath it, it says frequency list. And now this is where you would have to hit second L2 and then hit enter, and you're on calculate and hit enter. And now you would get the same thing I would get. So I have an old calculator, you might have a new calculator. But regardless, it tells us the average is 1.85. Now you really can't have 0.85 of the pet, but the average is 1.85, and this is the sum of the data. And down here, this is N. This means there are 40 kids in the class. If we add up all these numbers, believe it or not, we're getting to 40. So 74 divided by 40 gives me 1.85. So you could have written this out, you could have done it by hand, but why would you want to? Now here's the standard deviation, 1.57. So that's not really a big standard deviation. That, you know, the numbers are kind of clustered close together, and that's what that would mean. So your mean is 1.85. Median, what is the middle number? Well, guys, let's take a look at it like this. There were 40 kids. I could literally write 0, 0, 0, 0, 0, 0, 0. I could put 7 zeros. Then I would write the number 1 14 times. The number 8 2 times. That is crazy. If I want to get to the middle of my frequency, I would take half of 40, which is 20. And then what I would do is I would count to 20. 7 and 13 land me at 20. So I would have hit 20 in this interval right here. So that would be a count of 20. And then I would start from the other end, and I would say 2 plus 1 is 3. 3 and 3 is 6, 6 and 5 is 11, 11 and 8 is 19, and guess what? I hit my 20th piece of data in the same interval. So that is how I know the median for this is 1. The mode, the most often, would be 1. 14 kids in the class have 1 pet, so the mode is 1. And find the modal interval, where the modal interval would be this interval here, if I circled it. Sometimes they make the word sound kind of fancy. So here's a bunch more lists. Now, if you, do this without me, you have to clear your lists. Right now, I'm just going to do this one really, really fast. On the calculator, but the one thing I want you to see is if I didn't use the calculator, if the interval is 5 and I say a frequency is 6, this is 5 happening 6 times, or 5 times 630 if I was doing the mean by hand. 4 happens 10 times, 40. 3 happens 15 times, 45. 2 is happening 11 times, 22. and 0 is happening once. So there's no 0, but we add these up. We divide by this 45, the number of items, and we would get our mean of 3.09. Or we can use the calculator. Second, memory 4, and second, memory 4, and we can clear all lists. And now we can start again. If we go stat edit, I can put in list 1, which is 543210. Oops. 5, 4. And then I can put in the frequency, 6, 10, 15, 11, 2, and 1. And again, you double check your list to make sure you didn't make a mistake. Stat, calculate the variable statistics. My old calculator, list 1, going with list 2. And here is my I get 0.09, yep, just like I got here. My number of items is 45. And here's another trick though. Maybe I don't want to, half of 45 is 22.5. I would count 22.5 up, 22.5 down, and I find my median is 3. But now if we use these arrows, look at it, it gives us the median. It gives us our quartiles and our median. The median is the middle. That means we divided our data in half to get to the middle. But quartiles means I divided my data into 4 quarters. So the first quarter of data landed at 2. The second quarter of data landed at 3, and that's because these numbers are so high. The third quarter of the data landed at 4, and then all the data landed at, ended with 5. So here you can get all these things right on your calculator. So if you pause this video and you do now 4 and 5, you can then turn the video back on and check yourself and see if you got the same things, same answers I got, and hopefully you did. Now, what happens if they only give us a big pile of data like this? So this one's on your is on your packet without any stats being done with it. Well, the first thing I did with this by hand is I took these 15 SAT grades and I put them in order from smallest to largest. And if I put a single list, if I put it in order, and if I wanted to find the middle number, then I would have to go 15. I would count 1, 2, 3, 4, 5, 6, 7. Here's the 8th piece, the middle piece, and then 1, 2, 3, 4, 5, 6, 7. So I have 7 numbers lower than the middle, and I have 7 numbers higher than the middle because I had 15, an odd number. That would give me my median at 672. And then if I wanted to break this into quarters, I would say, okay, half of 7, I would have 3 and 3, and then there's that middle, 572. That would be my lower quartile or quartile 1. And the same up here. I would have these numbers. Here's the middle, and then here are these numbers. And here's my upper quartile at 750. Now, I could do this all just by listing my data in order, or I can go back to my calculator and I can go second, memory 4, enter. And now, when I go into my list, I only have one list. So if I wanted to put these 15 values into my list, I am just going to go up and down so I can move my calculator over. So I see 545 and 778 below it. Then I have 660, and then I have 800, and then I have 780, and 527. And then I have 665 and 680, 480, and 660. Now let me just move this to the other side of the 660. All right, now I have 572, 750, 672, 735, and 720. Now again, double check your list and then hit stat, calculate. But now with the variable statistics, I have no frequency. So with me, I can just hit enter. But with you, you have to cursor to the second row and you have to clear out. You have to delete list 2 on frequency and then hit enter. And now this is what we get. We get a mean of 668.266. I rounded it to 668. And there's my 15 pieces of data, so I didn't forget anything. And just like we had up here, we get a lower quartile. We have a minimum of 480. We have a lower quartile of 572. Here's the same median we found, 672. Here's my upper quartile of 750. Now, quartiles are important because if you had to do the box and whisker graph from 9th grade, first thing, your number line has got to be in order from smallest to largest, and you have to count in equal increments. These numbers are not in equal increments, but I'm counting by 50s. So 450, 500, 550, 600, 650, 700, 750, 800. And I stopped at 800 because if you recall, my maximum was 800, my minimum was 480. So here's my 480, here's my 800. And then the box comes from my quartiles. So my lower quartile was 572. So here's my 572, it's estimated. Here's my median, it's a thicker bar at 672. And here's my upper quartile at 750, and then that's what I make the box from, and then I draw my whiskers to the range. So the range, the overall range is the smallest to the largest, and sometimes they want what we call the interquartile range, which would be how big is this in here on the box? How is the work clustered together? So if you said 750 minus 572, you would have 8, and that would be 7, and so you have an overall range of 320, but you have an interquartile range of 178. So that's a lot smaller because your data is clustered in this box. And since this is quartile 1 to quartile 3, this is 50% of your data should be, most of your data should be clustered in this interquartile range. So here's a very common question. A lot of you ask me this. What do I need to get if I need a certain grade on your report card? Well, if Susie has these grades and she wants a 90, we have to go back to what we said at the very beginning, and averages, add up what you have, and what she has are 349 points. Here's the grade she didn't get yet, and she knows her 4 test grades, but this would now make 5 test grades, so divide by 5, and she wants a 90. So we need to put the 90 over 1 and make a proportion. If we solve this proportion, she needs 101. So she needs a perfect score plus a bonus in order to get a 90 on her report card. And then we did the problem again. What would, what if this was her grades? What would she need on her final exam if she wants an 80 average? So we added up her 4 grades and got 297. Now here's the final exam. Divide by 5. To get an 80 average, she would need 103 on her final exam. She's not getting an 80 on her report card because final exams do not have bonuses. And this is probably what did her in the fourth quarter. People like to call it senioritis. I call it laziness when people stop doing their work in the fourth quarter. All righty. So here's some more notes on what we said. What's a quartile? What's a median? And quartiles are brings us to what a percentile is. A percentile is a position of data. Let's just say you took a test and you got a, I don't know, an 83. Okay, an 83 is a great grade. So the 83 is a good grade for you, that's a B, but you're only at the 50th percentile, which means 50% of the class got what you got or less. A percentile is where the data is or less. If you got an 88 on the test, you got a B+. 75% of the kids in the class got what you got or less because quartile 3 would be the 75th percentile. So a 93 on the test, great, you got an A. But that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 20 kids got your 93 or lower. That means your grade was at the 90th percentile. That means you did amazing in terms of getting a nice grade, but also in terms of comparing yourself to your peers. So that would be the 90th percentile. So percentile means where your data is located and how many pieces of the data were where you were or lower. So you got to be careful between the word percent and percentile. And this is how your SAT scores and your PSAT scores come in the mail. The interquartile range, like I said, is the range from the upper quartile to the lower quartile. So when you have your data, so here's the data set, if we find the median is at 50, and the first quartile is at 23, and the upper quartile, third quartile is 76, we can make a box and whisker plot from the lowest to the highest, again, equal increments on the number line. Here's my lower quartile, my upper quartile, and then my median of 50. My interquartile range would be quartile 3 minus quartile 1. I have a 53 interquartile range, but I have an overall range of 81. So if we, again, did this using the calculator, we would put in list 1, list 2, and we would use variable statistics with both lists, and we would get a mean of 35. We would get a median at 35, and we even had a mode at 35. Everything was at 35. That's telling me this was some pretty good work. Now, the last thing to mention is the word outlier. An outlier is a data value that is greater than the upper quartile plus 1.5 times the interquartile range. In other words, an outlier is a piece of data that is so far outside of what most of the data is saying. So let's say you take a test in class, and let's say everybody fails the test. 19 kids fail the test, one person gets 100. Well, that one person is an outlier. Does that make sense? If it doesn't, you got to let me know. I'm not going to ask you to figure an outlier out, but an outlier is a piece of data that is so far away from the cluster of what most of the data is. We call it an outlier. So I am going to ask you to do 10, 11, and 12. And on 11, that's just a stem and leaf plot. You might remember this. The stem means the 9, and these are the leaves. This is the data value 90, 90, 91, 92, 96, 99. This is 80, 82, 83, 85, etc. So just, you could write your data out, but this is also from ninth grade that we want you to know. Okay, well, let me know if you need any help. Good luck.